Good morning, everybody. I'll give a little bit more time for those of you that are just joining. Welcome back to MakerBot Chats. My name is Felipe, Creative Director at MakerBot, and I'm live now from, again, my apartment, so live from New York City. Welcome. It's good to have you here. It's been a while since we did our last Chats episode. And this one is going to be a fairly technical one, so I'm excited for that. It's going to be about basically single versus dual extrusion. We are going to be talking about both the sketch platform, the method platform, and what are the implications of choosing one versus the other. Not only the sketch versus method conversation, but also single extruder versus dual extruder. Even when you have a dual extrusion system, such as the method, would you want to choose to just use one of them, right? So that's another option that you have with method. You can either decide to use only, to use both extruders at the same time, or just use a single extruder. For those of you that are just joining, I would like just to know, if you have any comments on the audio, because we are testing a brand new setup as well. It's basically a few things have changed now. We do have different. Let me change this. So we have different cameras here. This is one of them, which I'm going to be using to showcase the actual insides of the machine. So taking you guys through, the components inside of here for both sketch and method. And the second webcam, kind of our standard, just overlooking the whole action. So, without further ado, I just finished uploading my material here on the method. That's that. Let's get started. And again, if you have any questions, do post them in the comment section to the right of your screen. We'll be happy to answer them. And also, like if you're seeing the recording version of this, also post the questions in there. We are always trying to follow up with them and just answer any of your guys' pressing questions. So let's get started with the basics. What's the extruder and how do you use the extruder? So I have quite a few extruders with me today, starting with the method extruder. I also have the Rep Plus extruder. This is a experimental extruder. And I will talk also about the sketch extruder, right? The extruder in itself, it's similar, in very broad terms, it's kind of like a hot glue gun, right? It's going to take the plastic that comes in, so the filament coming in through the extruder, heat it up, and you see here my heating core element, and ultimately push it out of the nozzle. The whole idea is very simple. You want to heat the plastic and you want to keep it flowing at a constant rate, right? So we slowly or progressively have iterated on our extruder systems from something that resembled a lot, let me take out the sketch extruder here. Wait a second. There we go. So we've evolved our extruder technology quite a bit in the past couple of years. We started with something fairly similar to what the current technology behind the sketch extruder is, which is, it's a hot end, right? It's got the power supply right here, it's got the nozzle right there, and it basically just allows plastic to flow through. There's no real filament detection system here. It's just going to keep pushing the filament through and assume that everything is good, as you're printing. Next up, we have our smart extruder. The smart extruder, as sort of the name suggests, has a little bit or quite a bit more components to it, right? You can see it also in the connection board. So here in the sketch extruders, there's only like the power supply and the temperature readout pin that comes out of the extruder. With the smart extruder, you have quite more pins. I think this is a 16 pin board coming back to the printer. It's also a magnetically attached one. So this is the one that comes with Rep Plus. It comes with the Z18. And unlike what happens with the sketch extruder, this one actually is able to detect filament jams. What that means is that it has an encoder wheel here at the back. But the encoder wheel is going to be able to track the material flow. So it'll know not only the temperature of the material and the fact that it's moving along, but also if there's any issues with the material at all, if for at some reason it gets stuck, the extruder is able to detect that material being stuck and just pause the print, alert you, and allow you to make the change in the filament or in the extruder. And finally, we have the method extruder. In the method extruder, it's a similar architecture than what the Rep Plus extruder, but it's way more fine-tuned, right? A couple of things have changed, starting with the extruder length itself. So the length of the hot end itself, right? In the Rep Plus extruder is about half an inch, close to 3/4 of an inch at the end. With the method extruder, we've expanded that almost 3 times. And what that means is that the plastic has more time to actually to actually liquefy, and it allows us to have a much better control on the material flow, right? So we are making sure that the extruder is not just sticking, or it's actually handling better the material flow overall. It also has a much better gear system, so you can see here, there's almost like a gearbox inside of the method extruder. And what that does, it adds more torque to the extruder itself, meaning it's able to push the filament with way more force than what a Rep Plus extruder does. And that also means having more control over the filament, being better suited to actually, have a constant flow of material coming through, and ultimately that translates in better prints. Now, coming back to the idea of single versus dual extrusion, let's start with single extrusion. In the case of the sketch platform, and I'll put just a second, there we go, just putting the extruder back. In the case of the sketch platform, let me cut back here and move a little bit the camera so that you guys can see. There we go. I can also turn on these lights, which could help. It's too bright. Let's keep it this way. I think it should work. But basically with sketch, you only have the one extruder right here, right? So the material is going to only come out of that extruder. The way that I removed it, so I was just showing you the extruder outside of the printer. So what happens here is I press these 2 tabs on the sides and pull the extruder down, straight down, and then you get access to the extruder. Which, as I said, it's fairly, it's a fairly straightforward component. It's a hot end and the nozzle, right? Putting it back in, there we go. So with sketch, you only have the one nozzle, and that means just having one material. The material in sketch, moving the camera a little bit, actually, is coming to be quite a bit handy, having the moving camera over here. So with sketch, you only have one material, we only have one extruder, and that means only one material side loading to the printer itself. But in this case, I've loaded PLA, so it's this gray PLA spool. The spool gets fed through this little hole on the side. Let me bring you guys a little bit closer. So this hole on the side pushes the filament through and into the extruder, and that's about it, right? You only have the one material, and that means, let me flip back to my main camera, and that means that you're only going to be printing with a single material, right? So this is an actual build plate from Sketch, one that I printed a few days ago. As you can see, there's only one material coming out of the nozzle. As you would expect, because there's only one nozzle, right? So both the material itself for your parts and the support material is going to be the exact same component, in this case PLA, gray PLA. And that's great because it actually saves a lot of time. It can yield, it's a far more straightforward process, right? Great for when you're getting started, great for having that simplicity of use in the platform. However, there's certain geometries that are a little bit more complex to print, right? And I have a few examples with me right now. But there are some times where even printing with supports, and the supports is basically the structure, the scaffolding that's needed, with some prints, some geometries, in order to be able to print the geometry successfully, right? So this is my to-go example because I really like the appearance of the model itself. I think it's really interesting. It's a propeller, right? And you can see the 3 blades. Let's see, which one? Yeah, it might look better on the other camera. So it is a propeller, right? It's an interesting geometry overall, moving it here. However, as you can see, this propeller was printed oriented this way. As I'm printing the propeller itself, the blades need to have support underneath. They need to have some sort of scaffolding that is going to prevent the material from just straight falling down. Inherently, 3D printing, specifically with FEM, is going to slice the part in multiple layers, each of which is going to be printed on top of the next one, or of the previous one, right? So that's where supports come in. This other print showcases SR30 supports, right? So this white element is actually my support system. It's my scaffolding system, and as you can see, it accompanies the part slowly but surely going up as I am printing my component here. Now, with Method, you actually have access to this type of support, which is water soluble. This is SR30, so it uses water and an extra agent in the water in order to dissolve the support system, but you're left with a very clean part, right? So you're printing effectively with two materials, and we'll talk about those dual extrusion systems in a second, unlike what happens with the sketch. It all depends on how complex are your parts. Let me try to move back to, for some reason this is, there we go. It all depends on how complex your parts are, right? I could be working with something as organically shaped as this element. This one I designed with Rhino and Grasshopper quite a while ago, and as you can see, there's no way that I can print this object without having some sort of support system. There's no way that I can orient this part that will not require support in order to keep printing, the coming layers later on in time. So let's talk about what a dual support system looks like, and specifically the Method system, right? And I'll start going through some. Oh, the sound is echoing. Let me get rid of one of the mics. See if that helps with the echo a little bit. Hopefully this is better. Let's see. Let's try this. What about that? Hoping the sound is better, but let me know if you guys are still having issues with the sound. And for now, moving my trusty, let's see if this tripod actually gets all the way to the top with Method. If not, no, it won't. So I'll have to disconnect the webcam here in order to show you guys here, but I'll show you first the inside of the machine. Right in here. All right. So this is the inside of Method, right? What you're seeing here, when I'm pointing the camera towards, is a dual extrusion system that Method has. It has the material extruder, and it has the support extruder. These two extruders are going to be toggling back and forth between them as they print. So this is what we call the gantry. The gantry is basically following all of my movements along, giving you a little bit more context here. Cut. Let's see. All right. So, the gantry, let's see, let me try to cut here. There we go. So the gantry is all of these elements that houses both the extruders and the main motor heads, drivers on the printer. And it's, as we said before, for some reason it takes a while to cut, but it houses both extruders. Let me show you why or how the two extruders work. Basically, it's very similar. If you guys are familiar with what a typewriter used to do back in the day, I'm sorry, I'm maybe that old. I didn't use typewriters like a lot, but I'm familiar with them, right? So just look at what happens as I hit the edge of the wall, right? The extruder toggles back and forth and up and down. So right now, you can see that the extruder on the right, it's lower than the extruder on the left. If I toggle back, they switch over. Oh, sorry. That wasn't part of the camera here. So they switch over. So you see, let me put this like straight on to make it very clear. Higher up, and that on. Okay. So extruder 1 is a little bit higher than extruder 2. As I go all the way to the edge here, you see, it's very it's that motion, right? You see how it goes up and down? That's what allows me to toggle between the extruder heads, right? Up and down, right? So what's happening here is I'm allowing the extruder heads to print independently and not get in each other's way. The important thing about that is that actually makes sure, enables you to actually print your model without having one, you have to print one layer of material, then the layer of supports, and then toggle. Well, actually toggling between them. Why? Because each layer, and I'll bring back my handy test model here. So each layer now is going to be made out of both one section of actual print material and one section of support material, so, right? So that's the importance of toggling here. And now, speaking about access, you know, in the same way that what we just talked with Sketch, but access to the extruders here in Method is going to be similar, but also a bit different. So apologies for the movement in the camera, but I'm just hand holding here. Sorry. All right, here we go. So bringing this back, trying to put this in. Trying to frame this for you guys. There we go. So here I have my two extruders, right? Extruder 1XA, extruder 2XA. These are my standard Method X extruders. And the way to remove them is actually removing first the material, the PTFE tube. So that's actually the feeder, the feeding tube that's guiding my filament into the extruder. So removing this, there we go. And then I have a simple tab here that secures my extruder in place. So unlatching the tab, opening the latch, and taking my extruder out, right? And it's the same process for both extruders. So you can see like this is the exact same extruder that I had shown you before. The connector pins, the gearbox here, the hot end at the very end of it, and the process to get it back in, very similar, it's kind of the same. Nesting it, closing the latch, closing the lock, and bringing back the material feeding tube. And that's about it, right? And I have this system, you know, unlike what happened with Sketch before, this is a duplicate system. So it means I have two extruders here. I have my main material extruder and my support extruder. As I was saying, each of them is a dedicated extruder for each of the materials that you're going to be needing. The reason, well, it goes back to that. How complex are your parts? What are you trying to print? And with that, you know, I'm going to start to take some of the questions from you guys, just to be a little bit more. Oh, I think I just closed my question chart. So give me 1 second, just while I open it. But you know, that is like in a nutshell what we mean by single and dual extrusion. As you see, like it's a fairly straightforward system. In a way, it's basically whether you have one nozzle or two nozzles. But it can be a little bit more complex than that once you start playing with the minute elements of the system. I'll start taking some of the questions now. And again, if you have any more, do send them out to hello@MakerBot. But for now, since we're live, I'll be following through that chat, and Alejandro is on the back end just receiving all of the questions and letting me know how they come. So, is dual extrusion with one nozzle possible? No, it's not. You actually have to, I mean, if you're using a single nozzle, so if you're using a system like Sketch, you will need to use just one material, right? You cannot toggle materials with a single nozzle because you would need to hack your way around it, and it's going to be trickier than it sounds. So the straight answer is no, because you would need to swap materials halfway through, and it can be a real headache. And so especially you won't be able to toggle materials between layers. So as I said before, if you're printing with two materials, that means each layer now has two components, and it's impossible for you to pause between layers, in between a layer. How does designing for dual extrusion differ from designing for single extrusion? Well, in one way, it frees you, right, to actually have much more complex parts, like what I was showing you here. And that's kind of a question that I had for you as well. Like, if you have, you know, out of the parts that we have shown you in the past, if you have any favorites, if you would like us to talk more about specific ways of designing certain parts, whether it's, you know, something super organic, something super technical like the propeller. But what are the things that you guys are printing? And if you have STL files, we can always print them here, print them live, and show you guys what are the results that we're seeing here with the method. But basically, the main difference is, you know, designing for single versus dual extrusion. It just means when you have dual extrusion, when you have the soluble supports, you're able to not think that much in what's the process going to be like. You're just designing your part and focusing on the actual part, not so much the 3D printing process. What's the extrusion multiplier and how do you set it? I'm guessing you're talking about the torque rate, you know, with that gearbox that I was showing you before, in Method, and I think that the torque change is like 1 to 23 or something crazy like that. The gearbox is quite powerful in the Method extruder. The reason being is we really want to have a tight control over the extruder itself and how fast or slow the material flows. What is the extrusion rate? So the extrusion rate, yeah, okay, let me take you to MakerBot Print, and I can show you some of those settings real quick. Fading here to MakerBot Print. There we go. All right. Here in MakerBot Print, you have your standard settings, but you can also go to your custom settings, extruder, and retraction distance. Where is my? Sorry. I think it's done via the speed. Okay, speed outline, direction, layer height, number of shells, infill, print speed. I'm trying to. I forgot where actually the flow rate is, but it's possible to change it. I just need to find it. I think right now it's hidden, and we're working on one actual new update for this. That it's I would say it's super exciting, but it'll enable you to access those settings. I don't have the numbers, just the number available right now, but I'll look that up for you and send you that. What causes under extrusion? Under extrusion is basically cost. It could be many factors. Mainly, I would say sometimes it's because of the material being a little bit damaged, right? So, and by that I mean it can be too humid. It can have a lot of water content in it. It might not look like it, right? But just having the material exposed to the elements, it'll just start soaking up water or humidity from the environment. It'll damage it, and what that means is that if you don't have enough control over the material, your part will have these sort of gaps, right? It creates some like bubbles, because instead of pushing the material through, it's pushing material with high humidity. That humidity, you can imagine, it basically just evaporates and makes the part a little bit more brittle and hollow. Are 3D printer nozzles universal? Some of them are, I would say. Like, there's some certain standards, right? Most printers will start with a 400 micron nozzle. That's what we have in both the Method and the Sketch. You see some nozzles that are like tighter and smaller, and they are supposed to be, you know, dedicated for fine printing. I think that, especially with FDM, nozzles that are smaller than 400 microns are just really hard to control anyways. It's quite a dramatic change between the thickness of the filament and the thickness of the nozzle itself. So you don't want to have that be such a big disconnect, right? There's short answer, there are a few different sizes of nozzles, but I would focus less on the sizes of the nozzle and more in the material itself. So a brass nozzle, awesome for PLA, awesome for tough materials, awesome for like low temperature thermoplastics that are not abrasive. If you're printing something more abrasive like bronze steel, copper steel, even carbon fiber, you will want to use a steel nozzle, just because those materials can cause much more wear and tear in the nozzle itself. How often should you change your 3D printer nozzle? That it depends, right? The answer is it's highly tied to your setup and to how often do you print, right? What's your print rate? I would say that I've never seen a nozzle, like outside of, you know, legit like lifetime testing. It's really hard for you to wear out a nozzle, like maybe once a year, if that. But it all depends on the materials that you're using. If you're talking about carbon fiber, like what we just announced a couple of weeks ago, then it's a different story, right? Because that material is much more abrasive, it needs a different nozzle, and it has a different rate of wear. But for most low temperature thermoplastic materials, maybe once a year, if that. But it's going to require quite a bit of use before you have to replace that nozzle. How to solve oozing and stringing? Okay, that's a good question. I would say it's twofold, the answer. First off, with the temperature settings, so make sure that you're using, I don't know if you're using, so I'll state the question again. How to solve oozing and, what was it there? And stringing. Oozing and stringing. I can see it being caused by two main issues. it goes back again to controlling that material. So with Method, we have an active way of controlling the material's humidity, right? The material is all the time inside of a drawer. And that means, not only is it inside of a tight drawer that has actual seals all around, it also has humidity sensors that will tell you if the material has too much humidity content inside. So that's one way, because humidity in the material will actually cause stringiness, will actually cause some oozing. And the second really important thing to keep in mind is your print settings, specifically the temperature settings. If you're printing a material with too high a temperature, for example, PLA, I believe, should be printed at 180 or 210 degrees Celsius. I can check that here. Let's see. Yeah, so I think it's 210 with PLA. If you're printing with a way higher temperature, then the plastic is just liquefying too much, and it's just going to start dripping and oozing out of the nozzle. That's not giving you any extra, benefits. It's important to keep to the tested parameters, but I would say just look into those big features. First, the print temperature of the material, and second, whether or not your material is actually properly stored, inside a drawer, inside some sort of humidity controlled element. Even the sketch, right? Even the sketch has, as you guys were seeing here, has a little lid that prevents some of the humidity from coming in. It's not actively drying the material, but at least it's something, right? Because many printers out there, you'll see them just having the material to the side, and that's okay if you're printing, for a couple of days. But if you're exposing that material for a couple of weeks and leaving it outside without any sort of desiccant and any sort of humidity control, it's just going to be really hard for you to actually get good results out of that material, because it will just start absorbing humidity really fast. So I'll see if there's any more questions, but with that, I think that kind of covers most of the conversation today. Thank you guys so much for joining. And again, if you have any specific questions, any more ideas of things you want to print, I know that last week we did actually run the print strength test. If you haven't seen it, you can go to our YouTube channel. It's actually really interesting to see, which material is the strongest. We actually had our full-on testing rig here. We might want to do another one of those, because it's really interesting, and we only did it for tensile strength. So for the next episodes, I think we could do it for also not only tensile, but pushing the material instead of pulling it. But yeah, with that, this covers today's chats episode. You can reach us out at hello@MakerBot or felipe@makerbot.com, and of course in social media, both @MakerBot for Twitter and Twitter and Instagram. And yeah, always great to see you guys. Thank you guys for joining us today, and have a good day. See you.